Lesson 6-6, Point Slope Form.
Point slope form of a linear function is another way to express a linear function. This form is typically used when we need to create linear functions from other information. It's the easiest way to find it when we have very little information. We can also graph functions in this form by changing it to slope-intercept form, which we learned in lesson 5-3, y equals mx plus b. Point slope form is y minus y1 is equal to m, the slope, times the quantity x minus x1. In this form, y and x are going to stay and leave alone. x1 and y1 are the coordinates of your point. Obviously, I've hoped that you've realized at this point that you need two things for this particular form, a point and the slope. That's why we call it point slope form. x1 and y1 are your coordinates of the point, and m is your slope. Here's your procedure. Step 1 is to always find the slope. If it's already given to you, just continue on. If it hasn't been given to you, you need to make sure that you find your slope, just like we did in lesson 5-1, using the formula m equals y2 minus y1 over x2 minus x1. Step 2 is to plug the slope at any one of those points into the point slope form. Step 3 would be, if you need to graph the line, you should change it to slope-intercept form. Here's an example. Write a linear function that has a slope of 5 and passes through the point negative 1, 3. Pause the video at this point to give yourself a chance to do the example. Here's your answer. I have the slope and the point, so I can go directly to point slope form. M is 5, x1 is negative 1, and y1 is 3. So plugging it into slope-intercept form, which is y minus y1 equals m times the quantity x minus x1, gives me y minus 3 equals 5 times the quantity x plus 1. It's really a minus negative 1, but the double negative becomes a positive. I don't need to go any further in this particular example. Because it's not asking me to graph, I don't have to change it to slope-intercept form. Here's a graphing example. Graph a linear function of the line that passes through the points 2, 5, and 4, 11. Pause the video at this point to give yourself a chance to do the example. So the first thing I need to do is find my slope. I take the 2 points, call one P1 and the other one P2. 2, 5 in this case will be P1, and 4, 11 will be P2. Plugging them into my slope formula gives me a slope of 3. Now I'm going to plug it into point slope form. I take the first point and go y minus 5 equals 3 times the quantity x minus 2. Now to graph it, I need to change that to slope-intercept form. The first thing I'm going to do is distribute the 3 to both the x and the negative 2. That's how I get y minus 5 equals 3x minus 6. And then I'm going to add 5 to both sides so that I get my function of y equals 3x minus 1. I then am going to plot my points, starting at negative 1 on the y-axis and going up 3 and over 1 all the way through the graph as much as I can. Then I connect the dots from edge to edge on the graph, and I label my function on the graph. I always label it with my original function, not the one that I created in the slope-intercept form. So in this case, I want to label it as y minus 5 equals 3 times the quantity x minus 2. Here's another example. Write an equation of a line whose x-intercept is 5 and whose y-intercept is negative 3. Pause the video at this point to give yourself a chance to do the example. So if the x-intercept is 5 and the y-intercept is negative 3, my 2 points are 5, 0 and 0, negative 3. From there, I can find my slope. Plugging them into the slope formula gives me a slope of positive 3 over positive 5 because I have a double negative. Now I take that slope and plug it into my point slope form using either one of the points. In this case, I'm going to use 5, 0. So I have y minus 0 equals 3/5 times the quantity x minus 5. I then, to put it into slope-intercept form, distributed the 3/5 to the x and the negative 5. Y minus 0 is simply just y. If you're having issues with this lesson, please make sure you consult your teacher in class.